So today's material will talk about quadratic formula and AGM inequalities, which is what's going to be on your quiz. Okay, so your quiz, you'll likely have 3 questions. I'm gonna guess one is quadratic formula and 2 of them are inequalities. Not necessarily AGM, could be something else, which we'll talk about in a moment. Okay, could be something else, not necessarily AGM. Don't think all the questions are AGM questions. If you get stuck like that, if you always think like that, you might get stuck forever. So let's talk about quadratic formula first. Quadratic formula, first of all, A, B, C are real numbers, and we have a restriction which says A cannot be 0. Why do I emphasize this? So someone tell me, what happens if my A is 0? If
A0 is not a quadratic, it's a linear.
It's not quadratic, it's linear, exactly. Then we have a linear equation. My next question is, how many solutions does the linear equation have? Or how many real solutions? 1, that's correct. Why? Because a linear equation is a straight line. So they can only cross the x-axis once. So you would have a unique solution. Why do I emphasize that? Okay, 1 or 0. Well, if you have 0, that's going to be constant function. It's not linear either, it's constant. Yeah. Oh, constant function, you can either have like 0 or you have infinitely many. But we're talking about linear. Anyway, why do I emphasize that? Because, okay, here is a trap they can set for you. 2 different traps. They can say to, here, they can say, find values of A such that the following equations has a unique solution. And your equation might be something like, oh, ax squared. This is just something I made up, okay? Minus 2x plus a plus 2 equals to 0. Now, when you see this, you would think, oh, this is easy. Has a unique solution means that my D needs to be equal to 0. That is correct, but you're forgetting that what if A is 0? Then you would also have a unique solution. Does that make sense? So for this question, you would have 2 different cases. So you should have 2 different cases. One is when A equals to 0, you would have a linear equation which has only 1 solution. 2 is when your discriminant equals to 0, which means you have a unique solution as well. So this is a quadratic, but it has only 1 solution. Do you have any question? Did I lost you already? Question, is it clear? No, makes sense? Got it? Okay, cool. I want some feedback, guys. Even if you think it makes sense, tell me it makes sense. If you have a question, then tell me you have a question. Cool. So this is the first type of trap they can give to you. The second type, it's still based on A is not 0, is it can give you something like this. They say, given a quadratic equation, Okay, so they're like, oh, given the quadratic equation. Again, I'm going to use the same equation, ax squared minus 2x plus a plus 2 is 0. And they were like, oh, find values of a such that the equation has two distinct solutions. Now you're gonna think, oh, has two distinct solutions. What does that mean? That means my d has to be greater than or equal to 0. I mean greater than 0. So you think, oh, my d will be greater than 0. That is correct. But at the same time, you would think, oh, it's a quadratic equation. So a cannot be 0. So a cannot be 0. Okay, so again, you would consider a 0 or not 0. So those are two types of traps they can set for you and waiting for you to jump in. And I hope, since I mentioned it, I hope you don't jump in. Are we clear? We're clear. Cool. Now let's try example 1. So the first example is a quiz question from last year. It says for each of the following statements, decide whether it's true or false. Justify your answer briefly. So I'll give you some time to think about A. Okay, I'll give you 3 minutes to think about A. And after those 3 minutes, we will, I want you to type in the chat if you think it's true or false. Okay, 3 minutes, go. Go, go, go. Where is the timer? Where is my timer? Here, 3 minutes, okay? Start now. Can we see the question? Do you not have a copy? Let me send you a copy again. Make sure you try them because you learn math by doing it. You don't learn anything from watching me doing it. So make sure you try them. I'm trying to time you to give you the pressure you have during the quiz as well. 3 minutes should be enough for this question. Okay, just look at part A. Only part A. 3 minutes will be more than enough. Time's up, time's up. What do we think? The first one, part A, do you think it's true or false? If you think it's true, why is it true? If you think it's false, why is it false? Aaron, go ahead.
I think it's false because I think it should be b should be greater than or equal to 2 square root 3.
Okay, you think it should be greater than or equal to. Why?
So I took bx, I moved it over to the other side, so I had a quadratic equation. Once
Okay,
I had
just
a
hold on a
quadratic
second.
equation,
Let me write it down. So we
Wait,
have,
huh?
you're saying we moved the bx to the other side, like this. And what do
Yeah.
we do next?
And then with this form, we already know that for a quadratic equation to have at least one real root, we
Mhm.
have to evaluate its discriminant.
Okay, so what do we want the discriminant to be?
So our discriminant is going to be b squared minus 4ac.
So d is b squared minus 4ac, which is what in here?
It's b minus 12.
B minus 12. How did you
Well,
get that?
sorry, I simplified it. B squared minus 4 times 1 times 3.
Okay, so b squared or negative b squared?
Oh, negative b squared.
Okay, so it's negative b squared minus 4 times 1 times 3. Is that what you said?
Yeah.
Okay, then that's gonna give you b squared minus 12. And what we want it to be?
We want the discriminant to be greater than or equal to 0. So
Greater than or equal to
therefore,
0.
b squared has to be greater than or equal to 12.
Greater than or equal to 12. And what do we get for b?
That means b, I would it be right to say there's two cases? One where b is greater than or equal to positive 2 square root 3, and then one where b is less than or equal to negative square root 3.
That is correct. Okay, that is correct. Okay, so here, the key point here is has a real root. What does that mean? Okay, let me give you an example. I'm gonna say, I have a friend. Okay, my statement is, I have a friend. Does that mean I only have one friend? What do you think? I have a friend. Does that mean I only have one friend, a unique friend? What does I have a friend mean? It means that I have at least one friend. Okay. Another example is, well, I have a book. Does that mean I only have one book? It does not mean that. Okay, so has a real root is equivalent to has at least one real root. Okay, because of this, that's why you need the discriminant to be greater than or equal to 0. And that's why you can get the following statements. However, this is not a good answer. It's decent, but it's not good. So let me write it in a proper way to show you how you should write during your quiz. So first of all, it's a true or false question. Your first thing is you should answer the question. Is it true or false? So we think it's false. So false. Okay, and now you should tell me what does those mean. Okay, you should say, oh, by quadratic formula theorem, I'm gonna write the quadratic formula theorem, we know that the quadratic equation, what is my quadratic equation? Which is this? the quadratic equation, I'm gonna move it over here, and I'm gonna say that has a real root. When does it have a real root? If and only if and only if the discriminant, which is d, which equals to b squared minus 4ac, is greater than or equal to 0. And now you can say, oh, my d equals to this, which implies, so my d equals to this, which implies that b squared is greater than or equal to 12, which implies this. Okay, so your b can either be greater than or equal to 2 square root of 3, or less than or equal to negative 2 square root of 3. So the condition b is greater than 2 square root of 3 does not follow. From does not follow from x squared plus 3 equals to bx has a real root. Okay, so this is a complete solution. However, during your quiz, you might say, oh, I don't have that much time to write down this much. Then you don't have to write the conclusion. Like this sentence is not necessary, but everything else should be necessary in your answer. Okay, so let me read the chat and see if there was any question. When you did b is less than or equal to negative 2 root 3, did you divide both sides by negative 1? If so, why isn't b? Oh, no. So this is a calculus question. B squared is greater than or equal to 12. If you square both sides, that's gonna be, if you square root both sides, that's gonna be this. And this side is going to be absolute value of this is greater than or equal to this. Okay, and for absolute value, you know that it has a positive value and a negative value. So this can give you b is either greater than this, or b is less than, or less than negative of this. Okay. So this is basically telling you, oh, the distance from b to 0 is greater than square root of 12. So the distance is greater than this, which means it can either be here or here. Does that make sense to you? This is a calculus example. You should know this from calculus, okay? Question. Yes, no? Cool. Next, part B. Let's read it together since we're running out of time. Read it together. If x1, x2 are two distinct real solutions of this, then x1 minus x2 squared equals to b squared minus 4c. True or false? Doesn't matter if you think it's true or false. You think it's true? Why is it true?
I think it's true because so by the quadratic formula, we know that there's two real distinct roots. So with any quadratic formula, it's the two real roots are going to be negative b plus discriminant over 2a, and the other one's going to be negative b minus the discriminant over 2a.
That's correct.
And then when you subtract them.
Okay, just give me a moment. I'll quickly write it down.
Yeah.
It's gonna be negative b minus square root of b squared minus 4c over 2. And you want to subtract them. So x1 minus x2 equals to minus b plus b squared minus 4c minus b minus b squared minus 4c. What do we get from this?
You'll get just the discriminant, so square root d.
Okay, so those two canceled out, those two add together will be 2 times square root of b squared minus 4c over 2, sorry.
Yeah,
Over 2, which will be square root of b squared minus 4c. Okay? And what do we do next?
next you'd have to square both sides.
That's correct. So let's square both sides. That's gonna be b squared minus 4c. That's correct.
Yep.
Great, great. Any question? Is this clear? I think it is quite clear. Clear, cool. Next. Good job. Next, example 2. This is for you. Okay, do it yourself. We will do either 3 or 4. Let's do 3. I'll leave 4 as your homework. 4 is not hard. 3 is not hard either. AGM inequality. Okay, AGM. First thing I want to say is make sure you memorize the right thing. Because every year we have students who memorized the wrong formula and you keep using it, then you'll get 0 because what you are starting with is not even correct. Okay, that's the first thing I want to say. The second thing I want to say is do not start with what you need to prove. Okay, write it in red. Do not start, because people do it all the time, with what you need to prove. So what do you start with? You should always start with like a basic fact or something you know that's true. For example, AGM. Okay, those are what you need to start with. However, you would say, oh, but in lecture, I saw my professor start with what I need to prove. That is considered as rough work. Okay, sometimes for inequality, we start with what we want to prove. We eventually get a basic fact, but that is only rough work. Okay, a formal proof, you can only start with a basic fact, such as, you can start with a basic fact. The most common one is a plus or minus b squared is greater than or equal to 0. Okay, or you can start with AGM. So those are what you start with. Start with those. You should not start with what you need to prove. In rough work, can you start with what you need to prove, then your proof will work backwards. In rough work, you can do whatever you want, but in your proof, you should not do that. Okay, because we're not marking rough work. It's just for yourself. Do we have any question? That's the first thing I want to mention. Another thing I want to mention is, if you look at AGM inequality, you'll see that the first one works for any real number, but the second one works only for non-negative numbers. So if you want to use this one, you should tell us your x and y are non-negative. Does that make sense? Because they don't work all the time. They only works for non-negative numbers. So if you want to use them, you will say, oh, my x and y, they are both positive or both non-negative. That's why I can use it. Okay, you should mention that. Another thing, remember your x and y, they might not just be x and y, they can be anything. This is where I always tell my students, you don't consider them as x and y, you consider them as square and a circle. So this is basically telling you square times a circle is less than or equal to square plus square, circle plus square, sorry, circle plus square over 2 square. Why do I do that? Because, well, this can be anything. Okay, don't restrict your mind to x and y or a and b. They can actually be anything. That is why we talk about this. Okay, don't restrict your mind to just x and y. Also, you should also know that for AGM, equality holds if and only if x equals to y. This is also important. You should know this because a lot of time we will ask you to check. When do you need to check? If question asked you to check, or the question asked for maximum or minimum value. Okay, if the question asks for maximum or minimum value and you use the AGM, you should check when equality holds. We will talk about that in example 3. So let's read it together. Read it together. Let A and B be real numbers such that AB equals to 3. Without using calculus, find the maximum value of this expression. Okay, find the maximum value of this expression. This expression, think about this. When you want to find the maximum value of something, do you want it to be less than or equal to or greater than or equal to? So my question is, do we want 5 over 3a plus b squared be less than or equal to something or greater than or equal to something for it to be the maximum value? You need to think about this, okay? Okay, I see most of you got it correct. We want it to be less than or equal to something. So we want this. That's the first thing you should know because you know what you need to do. Okay, now my next observation is 5 is a constant. 3 is also a constant. We know that well, constant, they don't change, so you can ignore them. Constant, which means, well, it doesn't matter. You don't need to calculate the maximum value of them because they will stay the same. Okay, so you can ignore them. Can ignore constant. So what you're actually trying to do is you are trying to find 1 over a plus b squared is less than or equal to something. Okay, does this make sense to you? Our thinking process? Is this clear? We're not doing the proof yet. This is just how I think. Okay, cool. So now I look at this. I look at what's given to me. I look at what's given to me. This reminds me of AGM. I don't know if this reminds you of AGM, but this reminds me of AGM. I have something multiplied by another thing. So I have a product, okay? And I have summation as well, summation square. So this reminds me of AGM. So I'm gonna start with AGM. So by AGM. Is this color readable for you? Can you read this? Or should I change to another color? Let me change to another color. I feel like this is more. Okay, so by AGM, we know that AB is less than or equal to A plus B over 2 the whole thing squared, which equals to a plus b squared over 4, right? And we know that ab equals to 3, so since ab equals to 3, we would have 3 is less than or equal to a plus b squared over 4. Right? And now we know that, well, you have this expression, that means this cannot be 0. So I can divide by this. So since a plus b squared is not 0, we can divide it both sides by this. So that's gonna give me 3 over a plus b squared is less than or equal to 1 over 4. Now, observe this and what you need to find. I'm gonna say we're almost there. So what do I need to do to get this? We have this already. We have less than or equal to, but we need a 5 here, we need a 3 here. So what do I do? What's my next step? Anyone? Well, I want to get rid of the 3 here. And I want to have a 3 here. Yeah, go ahead.
I think there's like a proposition where you can say that A is equal to B.
Why do we need A equals to B? Now we want to get here. We're not done yet. We're not done with the maximum value yet. Times something. Yeah, we need to times something. Okay, someone said we multiply by 1 over 9. Let's say 1 over 9. If I do this, what do I get? Oh, those two canceled out. There's a 3 here. But what about a 5? What do I do? Times 5. Okay, so what we need to do is we need to multiply by 5 over 9. Okay, then I have a 5 here. So this will give me 5 over 3 times a plus b squared, which is less than or equal to 5 over 36. Okay, do we have a question? Is this clear? How I got here? Cool? Clear? How is that the maximum value? We'll get there. Now, we're definitely not done. Why? This is not the maximum value. What is this? This is an upper bound. When you get here, this is an upper bound. Okay, we know that this is less or equal to this. So it's an upper bound, but how do we show it's actually maximum? This is where I'm gonna say, okay, maximum, minimum, you need to check the equality, okay? So we know that AGM, for AGM, equality holds if and only if A equals to B. Okay, so my AB will be A squared, which equals to 3. So A would be plus or minus 3, which is B. Okay, so now you can say, oh, the maximum is this. So my maximum is 5 over 36. Does this make sense? Did I explain why we have to check this? If this doesn't make sense to you, you're like, oh, but upper bound and maximum, what's the difference? The difference is this. Let's say this is where you can be. This is my A. Okay, A is from here to here. We can include those two. So let's use the brackets. So let's say my A is from here to here. This point is your upper bound because, well, all of A is less than or equal to this point, upper bound. This is also your upper bound. Because why? Because your A is less or equal to this number as well. This can also be your upper bound. This can also be your upper bound. Okay, but they are not the maximum. The maximum is when you can actually reach. Okay, so this is your maximum. It's also your upper bound, but it's a maximum because you can actually reach this number. Does that make sense? So getting here is not enough. Getting here shows you this number is an upper bound. Okay, but checking that you can actually get this number will give you the maximum. What did you do for the second sentence statement? Here, I divided both sides by this. Because it's not 0, or you can say it's greater than 0. We know it's not 0 because this expression is in the denominator. Okay, any other question? Before we end here, will solution be posted? No, I never post solutions, but the tutorial is recorded. So you can check the recording. Question? Concern? When do you post the recording and where? You will check my Quartus page when I post it. Where is the recording posted? It will be posted on YouTube. So YouTube, if you search my name, you'll see me. Search my full name, you'll see me. But yeah, I will update on my Quartus page. When they are up. Any other question before we end here? A bit more, okay. Where do you want to see this? What about the solutions for the other question we're doing ourselves? I will cover the other 2 questions in my second tutorial, which is gonna happen in 3 minutes. And the tutorial will be recorded as well. So you can check the recording for the solution. Till the top, cool. Like here. Any other question? A bit higher. There's nothing here. The notes we wrote. What note? I don't have any other note. If you go higher, that's just my cats and my dogs. The unique solutions, they are right here. Do you not see them? Oh, it's getting stuck. It hasn't started yet. We're still in my last tutorial. Yeah, we'll start in 2 minutes. Hello, by the way. Yeah, I was scrolling, but apparently it's not projecting. So just give me a moment. There we go. There we go. There we go. Bye, people from my first tutorial, and hello, people from my second tutorial. People from my first tutorial, you may leave now. You don't have to stay. No problem. Let me stop the recording.